Hi, this is a supplementary Algebra 1 lesson covering lesson 115 in your books. A line, determining the equation of a line given another line that it's parallel to. And you'll notice one thing right off the bat that's different in this section. I have no graph on my board here, and this is actually using our knowledge of equations and what the pieces, parts of the equation of a line are. Excuse me. We will find out we actually don't need to graph the thing. If you're kind of wanting to see what a graph of it would look like, it's on page 422 in your booklets if you want to refer to that. But basically, okay, we have a line through point -1, -3 here, and this is example 115.1 in your textbook. And it's parallel to this line here, okay? So we want to determine the equation of that line. We're going to use our slope-intercept form equation of the line to determine what that equation will be. But first of all, let's look at this line they give us. They say this line, the one we're determining, is parallel to this given line, okay? And we know the slope, the m component of that, is the slope of the line. Now, if lines are parallel to one another, that means they have the same slope. They do not cross, they do not touch each other. Okay, so in order to do that, they must have the same slope, exactly the same excuse me, the same slope. They can have figure of parallel lines there on page 422 in your text if you want to refer to that. So the steps are the same for determining the equation of a line. We're going to determine the slope first, and we're going to determine that slope from the line they gave us. Now we notice this line they give us is a linear equation, but it's not in slope-intercept form. Okay, it's in that general form I mentioned in our previous video. And so what we have to do, we have to convert this into the slope-intercept form. Okay, so I'm going to keep the y on the left side, the y term. I'm going to move that 4x over to the right side by subtracting, and I'm going to keep the 7 on the right side. Now I need y by itself, so I'm going to divide every term by 3. That will leave me y alone by itself. And it look what happened. Every term turns into a fraction now. I get a -4/3 x plus a 7/3. And if I can reduce that, I can go ahead and do that at this point. In this case, I can't do that. That is the equation of my line here. This was in the general form. Okay, this is in the slope-intercept form. And I know this term right here, or I should say this coefficient with the x term, represents the slope, the m component of our line. So if the lines are parallel, that means the slopes are the same. So I use that same slope, -4/3 x plus b. Okay, now our drill is the same as it was in our previous lesson. Okay, how do I determine that intercept point? I'm going to take this known point they gave us right here, where the -1 refers to the x and the -3 refers to the y. I'm going to substitute those in to our equation. Okay, so y is -3, and it's going to equal a -4/3, and I'm going to put in a -1 for x plus b. Okay, that leaves me a -3 on this side, equals a -4/3 times a 1. A -1 is a positive 4/3 plus b. Okay, so then I take what I want to solve for b. I'm going to leave it here on the right side. I'm going to send the 4/3 over to the other side. So I'll have a -3 minus a 4/3, okay, equals b. Okay, I'm I'm going to bring this up here a little bit so we can see it better. I'm going to convert this minus, so what I'm doing, I'm subtracting a fraction, okay? So I need to have them in a common denominator. I'm going to change the minus 3 to thirds. Okay, to have a thirds as a common denominator, I'll need a times 3 in the denominator, a times 3 in the numerator. I'll get minus 9 thirds minus 4 thirds equals b. So I have a minus and a minus, okay? They combine together to a minus 13 thirds equals b. That is my y-intercept, okay? So what do I do with that bit of information? I put it into this equation here for b. Now I notice it's a negative value, okay? So I would substitute in a minus 13 thirds for b, which changes this addition to a negative, okay? So what do I get as my equation? I get y equals a minus 4 thirds x. That's the same slope as I had on the line they gave us. I substituted in, but now my new y-intercept is minus 13 thirds. And that is my equation of a line that is parallel to this given line, okay? And this is a linear equation. It represents a line. It's just in a different form. It's in the general form. We rearrange it into the y-intercept form, or I mean slope-intercept form, excuse me, okay? So this is the equation of a line parallel to this line that passes through this point. It's the same procedure that we used yesterday. So I hope that helps. Hope you could follow along. Hey, we didn't even need to use graph paper for this exercise, and you'll find out, I think, for the next a couple lessons, we actually won't need to use graph paper. We just need to know what the pieces parts of these equations of lines are, how to rearrange them into the form, like I said, so our eyes can see the information we need. The information we need here was the slope. The slope is not readily apparent in the general form. That's why we change it to the slope-intercept method. The y equals a number times x plus a constant. Bingo, that jumps out at us. There's our slope, minus 4 thirds. We can just plug it directly in to our new equation. So I hope that helps. Shoot an email or a text message with any questions. So long for now.